Today we're going to be looking at section 5.4, and we're going to be solving what's called a compound inequality, which is essentially putting more restrictions on our inequality other than just sending it off to infinity or negative infinity. So in a compound inequality, there's two different kinds. There's an and or an or inequality. When two inequalities intersect, that's a compound inequality, and essentially that makes the x value kind of cut off between two numbers. So when we're looking at a compound inequality, if I was saying something like x is greater than 52 but it's less than 72, that's giving us a restriction or a range of numbers to look at instead of just all of the numbers. So sometimes they write the inequality like this. Whenever you read this, you would say that x is greater than or equal to 3, just like if you were looking at this part here. And then you could say it's also less than 7, okay? So x is doing these two things. Whenever you're looking at this, and if you're looking at where x is actually at, it's between 3 and 7. So if I ask you what are examples in the solution set, okay, you could say that 3 is in the solution set because it's equal to that, along with 4, 5, and 6. It's not actually equal to 7 because it's just less than 7. So the fractions and decimals that are in there would also be something that you could include. So you could go all the way up to like 6.9, but you can actually get to 7. So when we're solving these, we're looking at trying to get the variable in the middle by itself, and then we're going to be able to graph these so you can kind of have a better idea of what these look like. So whenever you're looking at this, you have negative 2 is less than or equal to, and then you have x minus 3 is less than 4. So when we technically read this, the x minus 3 is greater than or equal to negative 2, but it's less than 4. Our goal here is to get the variable isolated in the middle of our inequalities. So essentially we have three parts of our equation right now. We have the left side, we have the middle, and we have the right side. The goal is still the same, to get the variable by itself, but by doing that and isolating this, we're working this in two different ways. When I get rid of the minus 3 and I plus 3, I can't just add it to one side. I have to add it everywhere to keep it balanced, which means I need to add it on the left and on the right whenever I solve. When I do that, I have negative 2 plus 3, that's going to be 1. In the middle here, this is gone and I just have x. And on this side, I have 7. So now that your variable is isolated in the middle by itself, this would be your final answer. X is greater than or equal to 1, but it's less than 7. So when I go to put this on my graph, I need to make sure that both of these points are on here. I'm going to start down here. So 1, 3, I'm going to go by 2s. Actually looks like this. So our first point is going to be at 1, and whenever we're looking at what points you've put there, you're looking at the symbol that's right next to it. So in this case, the 1 is next to our less than or equal to, or in this case, x is greater than or equal to 1, so that is going to be a closed point at 1. When I'm looking at the 7, 7 is nearest the less than sign, and it's going to be an open point. And then x is bigger than 1 but smaller than 7, so it's all of these numbers that are right in here. So essentially you're going to have two endpoints and they're going to be connected. And that's what your graph looks like. So it's obviously a way smaller solution set than it would be if you were just going off forever and ever in one direction. It's cutting it down to that more restricted set of numbers. Same thing on this next one here. This is another example of a compound inequality. They're just using the word and. Y minus 3 is greater than or equal to negative 3, and it's less than or equal to negative 8. So when I solve this, I'm going to solve them separately. I have y minus 3 is greater than or equal to negative 11. I'm just going to focus on this one to start with. I'm going to add 3. That's going to give me y is greater than or equal to negative 8. That's one of my stipulations for y, is that it has to be greater than or equal to negative 8. Okay, and I'm going to look at this one now. If I add 3, okay, it will look like this, and y has to be less than or equal to negative 5. So when I'm looking at this and I'm trying to graph, I'm going to have 2 points, one at negative 8 and one at negative 5. So on my line, I'm going to have a negative 8, 7. So it looks like that. Y is greater than or equal to negative 8, so it's going to be a closed point. and y is less than or equal to -5, so it's going to also be a closed point. Now, if it's bigger than -8, that's talking about the numbers to the right, but it also has to be less than -5, so that's the numbers to the left. These are going to intersect each other, which essentially means that you are going to connect those, and that solution set is very small. Now, sometimes you'll see some of the multi-step inequalities in here. This next one, you have just a one-step equation again that you have to do to get r by itself. So to get rid of the +7, I'm going to -7 to both sides. Remember, we're doing that everywhere on the left and the right. So 6 minus 7, that's -1. R is left in the middle, and then 10 minus 7 is 3. So when I go to simplify this, I'm going to have a point at -1. Or, I'm sorry, when I go to graph this, I'm going to point at -1, 0, 1, 2, and 3. Okay. At -1, remember we're looking at the point that's closest to that, so the -1 is going to have a closed point. And the 3, if you look at the point that's closest to that, that one is going to have an open point, like this. R is essentially in the middle of those two numbers. It's bigger than -1, but it's less than 3, so it's all of these that are in here. Now on the second one on the right side, you have a little more to solve to get p by itself. I'm going to start with the 7, -7 to both sides. I guess I should say all sides instead of both sides. So that would be -12, 3p, and then 22 minus 7 on the other side, that's going to be 15. Now, for the first time, you don't just have p isolated right away. We need to get rid of the 3, so we're going to divide. And again, we do that everywhere to keep it balanced. So -12 divided by 3 is -4. P is in the middle. And then 15 divided by 3 is 5. This would be our compound inequality. P is in the middle of -4 and 5. So -4 down here. We'll put a few points on here. Remember, we're looking at that point, so -4 is going to have an open point because it is going to be by our symbol that is going to be greater than or less than. So it's open. Okay. And at 5, it's going to have a closed point because that one is equal to. Okay. P is bigger than -4 but smaller than 5. That's all of these that are in here. These are our compound inequalities that are and situations where it's this and this. We're also going to talk about what happens if they contain the word or. Okay, so this is the graph of two inequalities that do not intersect, which basically sends them both in opposite directions forever. So for example, x is greater than 2 or x is less than 1. If I was going to put that on a graph, and here's 0, 1, like this. Okay. If x is greater than 2, if I was graphing this, that would be an open circle, and it'd be all the numbers greater than 2, which would be going to the right. If I graphed x is less than 1, that would also be an open circle, but it would be all of these going to the left. So essentially, it's the exact opposite of the compound inequalities that we just did. Whenever you're looking at this, it's all of the numbers except for this part that's right here in the middle. Okay? It cannot be this part in the middle. It can literally be anything else. Okay? So if I asked you what could it not be, again, that would be what the graph would look like if it was compound. So instead of what it can't be, it would look like this. Okay? Notice that those are opposites of each other. Okay? You would have this and this. Okay? So x could be anything except for the numbers that are between 1 and 2, so all those fractions and decimals. Now these are a little bit easier to solve because you're essentially solving just two different inequalities and putting them on the same graph. So I'm going to start out here with this first one. -2m plus 7 is greater than or equal to 13. I'm going to subtract 7. That's going to give me -2m is greater than or equal to 6. And then I'm going to divide by -2. Now, don't forget the rules that we learned. Dividing by a negative is going to change our inequality. So m is now going to be less than or equal to -3. This is just part of what our graph is going to look like. So we have to figure out what the other side says by solving 5m plus 12 is greater than 37. Okay. Now I'm going to minus the 12. So 5m is going to be greater than 25. And if I divide it by 5, I'm going to get that m is greater than 5. Okay, this entire thing is my answer. Okay, so the or does not mean you just only solve part of it, this or this. It's going to be that the answers go this way or the answers go this way. So m is less than or equal to negative 3, and m is greater than 5. So make sure that both of those are on here. Negative 3, 1, positive 1. So when I'm graphing m is less than or equal to negative 3, that's going to be a closed circle. The numbers that are smaller than negative 3 go to the left. And if I graph m is greater than 5, that's going to be an open circle. And all of its answers that are greater than 5 are going to the right. So this entire graph is our solution. It can be anything except for what's in the middle of those 2 points. Anything that's between negative 3 and 5, it cannot be one of our answers. It has to fall in that other range of numbers. Same thing here. Okay, if I was going to solve and graph this one, a plus 1 is less than 4, or a minus 1 is greater than or equal to 3. So minus 1, that's going to give me a is less than 3. That's something that I can graph. Okay, plus the 1 to both sides, that's going to give me a greater than or equal to 4, also something that I can graph. Okay, so I'm going to do 2, 3, 4, and 5. Okay, a is less than 3, that's going to be an open circle. And then a is greater than or equal to 4, that's going to be closed. So that's what your inequalities are going to look like. Okay, you can also turn this into a situation where you read a word problem. It says the human ear can detect sounds that are between the frequencies of 20 and 20,000 hertz. Write and graph a compound inequality that describes the frequency of sounds that humans can hear, and a second one that describes what we cannot hear. So you can hear the sounds that are between 20 and 20,000. So we can hear anywhere between 20 and 20,000. You can actually hear 20. You can actually hear 20,000, just something that's between that. Okay, so our x value, okay, is going to be less than 20,000. Okay, but it's also going to be greater than 20. If I wanted to graph what that looks like here, I would need to point at 20. I would need to point at 20,000 and do 20K for that. Both of those points would be open, and x is somewhere between that. This is my range of frequencies that I can hear. Now, for what I cannot hear, okay, that's essentially the opposite of that. I can't hear 20, and I can't hear anything lower than that. So I can't hear x is less than or equal to 20. And I can't hear anything that's 20,000 or above. So x is greater than or equal to 20,000. When we graph this, this looks like a or inequality. Okay, here's 20 again, and here's 20,000. Okay, greater than or equal to, so filled in going the opposite way, and filled in going the opposite way. Notice that the graphs are the exact opposite of one another. So that's your compound inequalities. Okay, on your homework, there's 12 questions. All of them are odds, so you can always go back and check those. Make sure you read the directions, and you're putting this in your homework notebook. Okay, you can always go back and watch examples again if you need to, or look at the completed PDF for the full work. Have a good day.